Hi guys, in this mini episode we'll be talking about Turingboard, which is a machine learning software developed by Rafael. Rafael is coming from physics background. He completed his PhD in astronomy and he left academia in 2018 to pursue data science, where he built this software Turingboard in his bedroom only, which took him around 1 year, and now he is selling the 1 year subscription and a lifetime subscription for this software. So the 1 year license is around $149 and lifetime subscription is around $379. So let's understand more about what exactly is this software doing and what exactly is symbolic regression. So, symbolic regression generates machine learning models which are simple, explicit, and explainable, which in contrast with neural networks and other ML models are more of like a black box, and it's difficult to get what it is exactly doing under the hood. So basically what symbolic regression does is it takes your input and output variables and convert them into a very nice formula which you can study and write down in the one line and basically reverse engineer it to understand the dynamics behind the variables. So usually when we do any kind of regression, we usually assume some kind of model and then we try to learn the parameter. We would assume a linear model, or we would assume some kind of non-linear, let's say neural network model or some kind of model. But there is some kind of assumption regarding the model which we will be learning, the number of parameters which we need to learn, and then we learn those parameters. But symbolic regression do not make any assumptions regarding the model structure. So it not only searches for the parameters, but it also searches for various different kinds of models in the model space. And since that model space in which it's searching is such a large model space, the speed for running such a software is very important. So implementation of Turingboard has been done in a low level language, and it also uses data parallelization technologies to make it faster. So there are various methods to search in an open-ended space, and Turingbot uses something called as simulated annealing to search within that space. So basically what simulated annealing does is it starts with a potential solution and then it looks into the neighboring solutions by making some changes into the initial solution, and then it selects whether we should jump to that neighboring solution if it is good, and if it is not good then it jumps to that solution to not tuck into a local minima with some probability, and that probability keeps on decreasing with time because as time passes on we don't want to jump much here and there to converge finally. So very popular software for doing symbolic regression has been Eureka, which has been popular among physicists and in that community. And Eureka used something called as genetic programming to search the possible space of the solution. Eureka is no longer commercially available. It was acquired by a data consulting company called as DataRobot. And also a recent paper shows that Turingboard performs better than Eureka on many physics inspired problems, and also managed to solve problems and find solutions for which Eureka could not find a solution at all. And Turingbot also performed better than AI Feynman on various problems extracted from Feynman lectures on physics. So this is really an exciting software for people who model mathematical variables, for physicists who want to derive new physical laws from empirical data, and this software has also been quoted by many research papers, including a recent paper by popular physicist Max Tegmark. So guys, this is a very nice and sweet example of a software built in the bedroom over a span of 1 year single-handedly by a person, and I wish Turingboard Rafael a very big success in future and hope you get many clients soon. I hope you like this video. See you in next video.